When considering the metrics and measurements of the software development or quality assurance, there's also the problem of defining what is the actual quality we are looking for, what sort of software quality we want to have. I know that this topic is something that could probably warrant an entire separate course on defining and measuring and collecting software quality information, so I'm just going to show a couple of ideas on the definition of software quality. I'm not saying that this is the only correct approach. I just want to illustrate the point on the problem on how to measure and how to say what is the software quality we want to have on our product and what's the problem of defining what is software quality. For example, there's a study on quality dimensions by Garvin. This study defines 8 different dimensions, which are performance, features, reliability, conformance, durability, serviceability, aesthetics, and the perceived quality, which all define from one dimension what actually is good software quality. For example, the performance is simple: how fast this car goes, how good miles per gallon this car gets, how long battery life this product has. The features are the additional characteristics of enhancing the appeal of the product to user. For example, the availability of different apps or different services. Reliability and durability are related into the software or product life cycle. How reliable the product is, how probable it is that it fails, or durability, how long is the product's life cycle. Also, can the product be repaired, how costly it is, and overall for how long it is economically feasible to keep the product in use. Similarly, the serviceability, how easy the product is to fix, is also related to the durability. The other ones, the conformance, it mostly means about the specified standards, like how well it provides some service. For example, how does it conform into certain networking protocols, or what sort of GSM protocols the phone supports. The aesthetics and the perceived quality are related into the design. On the subjective actions, so how good quality the user perceives when they are using the product. Anyway, these measurements more or less define different approaches into quality, considering that if you go to someone and ask what's your opinion of good quality, it's probable that it's some of these dimensions, or permutation or combination of these dimensions. Overall, the Garvin also defines 5 main types of quality, which usually are some versions of these 8 dimensions. The transcendent quality is simply the gut feeling. You can't explain why you think this product is of high quality, but you know it when you see it. On the other hand, the product-based quality means that, for example, this mulcher is really energy efficient, or that this chainsaw is really powerful and it can cut down trees. Also, something like this ice cream has 0 sugar in it, or something like that. The product has excellent attributes. The product has excellent attributes on the areas which we expect them to have. Similarly, the manufacturing-based quality means that the product has excellent components, meaning that the product itself may be something which isn't really the focus of the quality, but it's built from excellent and durable components, meaning that the entire system is of good quality when all the components are of good quality. Usually this is related to some products which have durability issues like power tools or normal tools or these sort of things. If all the components are good, then the manufacturing value or quality is also good. Finally, what's interesting is the value-based quality. It more or less means that the product offers excellent service for the price or is excellent product for the price, meaning that there's a cost-effect ratio being considered. The value-based quality simply means that if you have 100 euros to use for running shoes, then what's the best quality you can get for 100 euros? On the other hand, if you put 800 euros into running shoes, you probably end up having really excellent shoes, but on the other hand, they are horribly cost inefficient, so their value-based quality isn't that good. Finally, the user-based quality is the most used quality, for example, in marketing. The product is exactly what the users seem to like or seem to need, meaning that the product is able to make the targeted user audience consider the product of high quality or at least of enough quality to warrant their purchase. Overall, there's also international standard for defining quality, especially in software product quality. There's also addition for this model for the software service, but it's more or less the same idea. We have certain components. For example, here we have quality attributes: functional suitability, security, reliability, compatibility, performance efficiency, maintainability, usability, and portability. They all have sub-attributes or measurable characteristics which we can use. For example, on security, how long it takes to break into the system, or reliability, how long it takes the system to fail, compatibility, is it compatible with all the other components of the system, performance efficiency, how much work does it get done, and so on, with the idea that if we select the important quality attributes, create our metrics based on these required or preferred quality attributes and enhance those, we also end up enhancing the product quality. Of course, there's some merit into this thinking. It's an engineering idea. We define certain components and we define them so that we can measure them. If we measure them, we know how to improve them, and if we improve them, the quality improves. Well, this in most fundamental levels probably yes, but we also have to keep in mind that of course the product also has the perceived quality and the users have their own preferences. So what we usually end up increasing is the mechanical or technical quality, while the perceived quality or the gut feeling of quality may not increase that much. Overall, there are several models and several definitions which follow the same ideas. We have dimensions or attributes or measurements or metrics, and if we create or define the metrics we want to use and improve on those metrics, we get better quality. There's some truth into it, and it's probably the most usual and most usable way of measuring quality, but it has to be kept in mind that the perceived quality and actual quality are two different things. The perceived quality is the quality that the users or the developers or people in general see or feel, or the idea of quality they have, and the actual quality is something that's more measurable, or that is the composition of all the quality of the components, the quality of the different functionalities, and the quality, for example, of the user interface or how easy the system is to use. So we can increase the perceived quality, for example, by using more high quality materials on the external case and defining more nicer user interface, but the actual quality may still be bad if the system is built of bad components. Anyway, in any case, this course is not about quality, but the quality is important thing to understand when we want to have metrics or see that our testing and quality assurance work goes towards the right direction. Therefore, it's usually good information or good idea to identify what's the preferred quality in organization, because actually, interestingly, if we ask from software project manager, the developer, the tester, and for example the marketing person or the client, what's the quality attributes from these 8 attributes they actually prefer to have in their products, you probably may end up with the completely different answers. That's because the developers want to see the product being stable and efficient. The testers may want to have the security and compatibility and the maintainability or usability in a good place. The marketing might be interested in portability and compatibility so it can be sold to different places, and the project manager wants the system to be efficient and stable and suitable for the work so that the entire project seems successful. So, the identification of the important attributes, whether they are from the ISO IEC 25010 or from the Garvin's dimensions, are actually important so that the metrics and measurements can be designed. On the final note, I want to point out that even though all these measurement methods exist, they really usually drop the ball on the aspects such as user is having fun or that the product gives the intended user experience for the user. This, of course, being a larger problem in the software engineering, for example, the UML definitions do not support these sort of activities at all. But overall, on defining what is software quality, the idea is that, well, there's several definitions for it, there's several models for it, and the best way to define quality is to make the definition on what we want the software quality in our case to be. What is the most preferred scenario and important aspects? Based on that, define the metrics, and based on that, use the quality assurance to ensure that the preferred matrix and the preferred measurements are fulfilled to the best degree that we possibly can.